Okay, so we're going to have a look at a problem here where we've got a unit square. Inside it we've got the arc of a unit circle here. Inside this we've got a little circle which is tangent to two sides of our square and also tangent to the big arc. And we've got a smaller circle in here which is tangent to this side of the square. It's tangent to this arc and it's also tangent to the other mid-sized circle. We need to find the radius of the smallest circle. Okay, so you can pause the video now if you want to have a go by yourselves, and we'll have a look at a solution. Okay, so the first part of solving this problem is going to be finding the radius of this medium-sized circle, and I'll draw a nice big diagram to show what we're going to do here. Okay, so we know that these two lengths of the square are 1. We also know that this length here is 1 because this is the radius of this unit circle here, isn't it? And we also know that the total diagonal length here is the square root of 2. So what we're going to look at doing next is finding the radius here, which I'll call capital R. And we'll have 1 plus capital R plus something else here is equal to the square root of 2. So in order to find out this remaining length here, I'm going to draw in some extra lines, and what you'll see is we've actually got a little triangle here, right angle triangle, R, so this one has to be root 2 times R on the hypotenuse. Okay, and what that tells us is that 1 plus root 2R plus R, if we added together all of these different lengths, this length here plus R plus 1, we know this is all equal to the square root of 2. So then we can rearrange here, root 2 plus 1 into R equals root 2 minus 1, so R equals root 2 minus 1 over root 2 plus 1. Next we're going to rationalise the denominator, get this in a nice simpler form. So we multiply by 1, which is equal to this fraction. Nothing changes on the left hand side, and then what we'll get is on the top root 2 times root 2 and then plus 1, so we'll have 3, and then minus root 2 minus root 2 minus 2 root 2, and on the bottom we'll have root 2 squared minus 1 squared, so 2 minus 1, which just gives us 1. So here capital R is equal to 3 minus 2 root 2. Okay, so next we're going to, now that we've found this radius, we're going to try and find the smaller radius. So first thing I'm going to do is draw another huge diagram, and basically the method I'm going to use here is using some trigonometry. We'll draw in some extra triangles onto the diagram and use some Pythagoras to try and work out the remaining some side lengths, which will tell us eventually what the radius of the smallest circle is. Okay, so first things first, I know that the total length along the bottom here is going to be 1 unit. And what I'm going to do is I'm going to set up some triangles to draw so that I can get an expression for the width here in terms of big R and small r, the small radius, and set this equal to 1, and then I'll solve this to find the value of small r. So the first right angle triangle I'm going to draw in is going to be this one. Right angle here, this is perpendicular. So if I call the radius of the small circle small r, then the height here is small r is this radius, and this length here is 1, this is just the radius of the big arc. And we also know the height of our square is 1 unit. We've got small r here, so this is going to be 1 minus r here. And what that tells us is this length along the bottom here is going to be the square root of 1 plus r all squared minus 1 minus r all squared. So let's go over here. 1 plus r all squared minus 1 minus r all squared. Take the square root of that. That's going to be equal to the square root of 1 plus 2r plus r squared minus 1 minus 2r plus small r squared. Okay, and then we'll actually see here several of our terms are going to cancel, which is very nice. 1 minus 1 r squared minus r squared. All that we're left with then is the square root of 4r, which is 2 root r. So what that tells us here is that this length is 2 root small r. Okay, so let's draw in some more on our picture. I know that this length here is just going to be capital R, which is great. And now what I need to do is try and find this remaining length, and how I'm going to go about doing that is I'm going to look at this length as part of this right angled triangle here. Okay, so I know, let's have a look at this length here first of all. I know the height of this rectangle is small r, and this length, the total length of this line is big R. It's the radius of the larger circle. So this length here is capital R minus small r. Okay, so to find this length we also need to work out the length of the hypotenuse, and to work that out we actually know, okay, this line here is R, this line here is capital R, and these two circles are tangent to each other, so this forms in a straight line, so we have R plus big R. So to work out this remaining side length here, we can use Pythagoras. R plus R squared minus R minus R all squared. Okay, so what we need to calculate is R plus R all squared minus R minus R all squared. So we'll expand, we'll do the squaring. R squared plus 2 big R little r plus small r squared minus r squared minus 2 big R small r plus small r squared. And then, just as we did earlier, lots of things are going to cancel. This big R squared is going to cancel with this one, this small r squared is going to cancel with this one, and all we're left with is 2r, r, and then plus another 2 big R little r. And what that gives us then is the square root of 4 big R little r, which is 2 root big R little r. Okay. We can add this to our diagram here, 2 root big R little r. Okay. And then we know that this total length here is equal to 1, so what we've worked out here is 2 root r plus 2 root r root small r. I'm going to write this as root big R root little r plus capital R is equal to 1. And what I can do now is I can rearrange this to find an expression for root r. So I'll have 2 plus 2 capital R root small r is equal to 1 minus big R. So the square root of small r is equal to 1 minus r over 2 plus 2 root big R. And what we're going to do is our next step then is going to be solving this to find small r by substituting in our value of big R. Just before I do that, I'm going to save us a bit of time and effort by rewriting 1 minus capital R using difference of two squares. So 1 plus the square root of r times 1 minus the square root of r. And the reason I'm doing this is because I can factorise the denominator here into 2 times 1 plus root r, which makes life simpler for us because these two terms cancel and we get 1 minus root r all over 2. Okay, and then I can square both sides of this equation. I get r is equal to all of this squared, so I'll get 1 minus 2 root r plus r all over 4. R is 3 minus 2 root 2, so I'll have 1 plus that, so I'll have 4 minus 2 root 2, and then minus 2 root r, which is 3 minus 2 root 2, all over 4. And then we found the value of small r, but I'm not quite finished here because I can actually write this in a slightly nicer form. So if I go over to the other side here, what we'll notice is 3 minus 2 root 2, we have the square root of that, let me write this as the square root of 2 minus 2 root 2 plus 1. And perhaps you're seeing the sort of structure here is that this looks awfully like we may have expanded some sort of quadratic to get this. And you can actually write this as root 2 minus 1, root 2 minus 1. So the root 2's give you this 2, and then your minus 1 root 2, your other minus 1 root 2 give you your minus 2 root 2, and these two negative 1's give you this 1. And then this tells us, so root 2 is bigger than 1, so this is going to be root 2 minus 1, because it has to be a positive square root here. So that's interesting, because now I can actually replace this term just by root 2 minus 1. Don't forget I have to multiply this by 2. So r is equal to 4 minus 2 root 2 minus 2 root 2 minus 1 all over 4, which is going to give me, so 4 plus 2 gives me 6 minus 4 root 2 all over 4, and then I can rewrite this as 3 minus 2 root 2 over 2. So r is equal to 3 minus 2 root 2 all over 2 is our solution. And notice here as well that 3 minus 2 root 2 is our big R, so actually our small r is just half of our capital R there. So this is actually equal to capital R over 2. Okay, great. Hope you enjoyed that.